Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews, contracting, and on-site training. Now, I know some of you probably wonder why I keep leaving the and on-site training in my intro, and that's because these videos have a long life on YouTube, and I do assume that at some point we will get back to on-site training. Now, if you happen to be watching this video in the distant future and you have no idea why I would have said this in January of 2021, or roundabouts February, whenever this will air exactly, well, don't worry about it. In this episode, I want to discuss CRTP. Now, CRTP is this weird thing. CRTP. Now, sometimes people get this acronym mixed up. Excuse me, it's an initialism, not an acronym, to correct myself there. It is the curiously recurring template pattern. And this basically happened very early in the days of template support in C++. There was someone, I don't recall the story for exactly who, noticed, hey, I keep seeing this particular pattern come up an awful lot. It is curious, and it got the name, the curiously recurring template pattern. And it kind of makes it look like a class is inheriting from itself. So if you see something like this, this is where the CRTP has occurred. It's where I am inheriting from a template and passing myself in, my struct, as a template parameter. Now, there's all kinds of rules in the C++ standard for why this is allowed, when and how you're allowed to refer to types before or not, if they've been considered complete and that kind of thing. It's allowed, and it happens. And I feel like it's a pattern that I'm seeing less and less, actually, personally, but it does come up from time to time. So let's take a look at what some template might look like. Now, with the case of all of my examples in C++ Weekly and any of my YouTube talks or conference talks or training material or whatever, I'm using struct here simply because it's simpler, because everything is by default public. In C++, struct and class are the same. The difference is that a struct is default public and a class is default private. So I've declared this as a template struct now, template class, whatever. And this, my struct, is what is becoming the CRTP parameter. And in here, I can do things. Now, it can be used in a way to create mix-ins in C++. So to give an idea what that looks like, let's say I am going to provide the less than operator. Now, if you have a strictly orderable type and you have the less than operator available to you, then you can derive all of the other operations. Now keep in mind, in C++ 20, what I'm doing would actually be considered bad code because we have the spaceship operator, and I've done a previous episode on the spaceship operator. I am using this as an illustrative example. So I'm just going to declare this. I'm not going to actually try to implement this at the moment, but I want to now provide the ability to have, actually, no, let's go ahead and implement it, sorry. All right, so I've got this simple less than comparison here. Now I want to have two of these things. Okay, so I actually implemented something that's going to work here to just prove a point. I want to see if these two things are equal to each other. And I have this, there is no operator equals equals available here. Fine, okay. Now, what I want to do is provide the operator equals equals using my sum template in a CRTP mix-in kind of pattern. Now, I know that and by I mean some template here. I know that this object that my current view of the world inside operator equals equals is actually an object of type CRTP. I've been given that guarantee. I've said the only proper way to use this is if you pass in the struct that you're currently declaring here. So I know that I can actually safely do this. I can do a static cast of this to a type of const CRTP pointer, because when I'm executing this function, I am an object of type myStruct, and that is ultimately what CRTP is here. Okay, so why did I do that? It's because I want to take advantage of the operator less than that was provided for me here. Okay, so now this statement becomes safe. I know that this thing that's passed into me on the right-hand side, now some template, I left out the template parameter, you're allowed to do that. As of C++ 98, if you're a really old school programmer, you might have still found yourself doing this, but it's redundant. You're allowed to leave that out as of the standardization of C++ 98. So no big deal. Actually, it might have been C++ 03. Pretty sure it was C++ 98. Okay. So I have implemented, I've called this less than here, safely and legally. But what I need to do is say that these two things are considered equal to each other if neither one is greater than the other or less than the other. So if the left-hand side is not less than the right-hand side, and the right-hand side is not less than the left-hand side, and these things are strictly orderable, then they're equal to each other. And so I see here that I'm actually getting false returned from main. I'm getting 0 returned from main, where I'm comparing these two things for equality, which I know they can't be equal because I have incremented this current value. Now I'm going to take this out so that they're both initialized with 0, and we should see that main is in fact returning 1. All right, cool. So if I make it so that they're different values, then the compiler is smart enough to see through this and optimize it. Now, what I've done is all I had to provide was the less than, and then I'm using CRTP here to provide the equals operator. And in fact, there is an entire part of Boost library that gives you all of these comparison operators just based on the ones that you provided. You give it a less than, it implements all of the others similarly to this. Now, of course, you would want to write some helper functions and stuff to make this code a little bit simpler to write. But as you can see, once we've got less than and equals to, it's quite easy to implement not equals. And in this case, we don't have to do the static cast because we can just call our own. And there we have not equals. And then we can similarly implement less than or equal to, greater than or equal to, less than, greater than. That would round out all of our comparison operations. So there you go. This now some template should probably actually be called something like that. Now I know there are people who don't like calling these mix-ins because they're not really the same thing as like a mix-in in Python or Ruby or something like that. But we can do something like that, and then we can format this nice and neat and have our nice little example here. So I will put a link to this example for CRTP in the notes and the description for this video. But keep in mind, like I said, that if you're in C++ 20 and you have access to Spaceship Operator, do use that instead. So thanks for watching this episode of C++ Weekly.